Alrighty, so like I said, our big focus is going to be on the normal probability distribution, and then you'll be doing a little bit on sampling distribution as well. So as always, guys, you have your reading and viewing assignments, but obviously you'll see there's nothing under our learning activities. So, again, make use of those resources. Now, for the activity that we were going to be working on is going to be this one right here. So let me share this file with you. So in your chat, you will see the link coming through for this document here. So, we're just going to try and see how we can work with normal distribution, just in an application way. I didn't mean to do that. Oh, how do I exit? There we go. Okay. So basically what we're trying to figure out here is how we can use normal distribution to figure out, are we creating a good set of, bowling balls that need to be delivered. So basically we are saying that a factory that makes bowling balls is trying to make 15-pound balls. They have a shipment of 10,000 that they need to send. Now, if the bowling balls are less than 14.9 pounds, then they will consider too small to use. So, you're kind of saying, okay, we know the balls have to be 15-pound in weight. If, you have a shipment of 10,000, well, you can't really weigh each of those 10,000 bowling balls because that's going to take a long time, a lot of manpower to try and do that. So the idea is, instead of trying to take all 10,000 of them and try to weigh them, obviously we do sampling. So we're choosing 3 different samples out of here, probably randomly taken at different times, different days, to try and get those. And the idea is, if the balls are less than 14.9 pounds, then, obviously they cannot be included in the shipment because they would be considered too small. So they want to make sure that they are making proper bowling balls without having to test all 10,000. We are saying, assume that the weights of the bowling balls follow a normal distribution. They have randomly drawn 3 samples from the 10,000 for testing purposes. And you can see these are the weights listed for all of those samples. So basically, based on these samples, determine if the factory is sending out a good shipment or not. Your decision needs to be made using z-values and the normal curve chart. Show your work and justify your reasoning. So since you guys are doing this as a class activity, you're not really submitting anything. So here is the template that I have created for us to work on. And you guys will be able to type into this. So here's the second link coming through for this spreadsheet over here. So you should have the instructions on that first link I sent you, and then the template you are working on the second link that I just sent you. So you should see that second link coming through chat. Okay, wonderful. George, I see you in the second one. So, you guys have actually worked on z-scores back in chapter 3. When we were talking about measures of position, they actually do introduce you to z-scores at that time. So that's the same exact calculation you are using over here when it comes to finding your z-score. And you will see on the right-hand side of your Google Sheets here, I have included that basic formula for the z-score. So basically, you take your data value, which in this case will be the weight of the bowling ball. You would divide it by the mean, and then subtract the mean from the data value and then divide it by the standard deviation. So obviously those are the 2 crucial values we need to come up with. So going back to our instructions over here, reading what information is given to us, what would you suggest our mean and standard deviation needs to be? So we know what each of the samples are. We know what the weight in each of the samples are. They're telling us that, you know, this is a shipment of 10,000 balls. They need to be around 15,000, sorry, not 15,000, 15-pound balls. And if they are less than 14.9 pounds, then they will obviously not be, you know, part of the shipment. So looking at all the information that's given to you, what do you think we should consider the mean and the standard deviation for this example? You can unmute yourself or you can put your answer in chat.
Would the mean be the 15-pound balls?
Very nice. Yeah, because that's what the shipment is about. So very good. That will be our mean. And then how can we figure out what the standard deviation needs to be? So while you're thinking of that, I'm going to go ahead and put our 15 in here for the mean value. So look at the information they're telling us when they say, you know, the ball would be too small to be considered, because that's kind of telling you what kind of threshold we can have. So based on that, what do you think our standard deviation should be? So we know the mean for all the balls has to be 15. They're telling us if the balls are less than 14.9 pounds, they will be too small to be considered. So what should our standard deviation be? Because, you know, on the other side, if it's less than 14.9 pounds, then on the other side of the mean, what would make it too heavy? Because you could honestly make the balls too heavy also, right? So what should that level of too light or too small or too big should be, which will determine our standard deviation?
Would it be 15.1?
It would be 15.1, yeah. So basically what's happening over here is, just to figure out what our standard deviation is going to be, you're literally just taking, you know, this is what we want the weight to be. They're telling us if it is going to be too light, that's going to be at 14.9. So yeah, if you go ahead and subtract that, you know, obviously you can see that comes out to be 0.1. So that would be the same thing, you know, if you add that back into 15, you would end up getting 15.1, which again tells you, you know, that's probably going to be too heavy of a ball that we cannot use. So that 0.1 actually ends up becoming your standard deviation, just that difference between what is too small and what we are hoping, you know, our average weight is going to be. Everybody okay with that? Yeah, okay. Alrighty, so that will be our standard deviation. So we're going to go ahead and put that in here. So now, I'm not sure if the rest of your classmates are going to come in. So what we will do is I'll give you guys a sample each, and you guys figure out what the standard deviation is, and I'll go ahead and put in for the third set. So you are basically going to take the data value, and you can see I've already copied them over. These are the same data values that are listed over here, and I've already copied them over here. So all you need to do is start by calculating your z-scores. And I'll show you down here, since I'll go ahead and do set 3. So basically, to calculate your z-score, now you can obviously do this by hand, or, you know, you can use the built-in functions to help you out. So remember, you take your data value, which will be the weight for that bowling ball. From that, you subtract your mean. So if you wanted to use cell reference, you can do that. Just click on the mean over here, or you can just type 15 if you wanted. So you're basically trying to match this formula here. So you take your data value, from that you subtract the mean, and then divide it by your standard deviation. So what you would need to do is, because there is a subtraction and a division involved, go ahead and put this in parentheses. So when you type this formula in your cell, put that subtraction in parentheses, and then divide by your standard deviation, which will be 0.1, and you will see that will end up giving you what your z-score should be. Now, do you guys remember basically what a z-score is? What a z-score tells us, what kind of information? So you guys did, let me see, the empirical rule and z-scores in, I believe it was section maybe 3.2 or 3.3, somewhere in chapter 3. Anyways, so the idea of a z-score, it basically tells you how far away you are from the mean. If you put that on that normal distribution curve. So basically the idea is, you are looking for, if you are at one standard deviation away, which means if your z-score comes out to be +1 or -1, which means you have reached that threshold of 0.1, which means you are now right at 14.9 pounds or right at 15.1 pounds. Now, if you're going to be, a number which is less than -1, or a number which is greater than +1, then that will actually tell you your ball is too small or too big. But if you're going to be within -1 and +1, then that tells you you are within that one standard deviation away from your mean. So the z-score is technically still a standard deviation. The negative number tells you how far you are below the mean, and the positive number tells you how far above you are the mean. So what we'll do is, I guess I'll just give you in the order it shows up. So George, you can do sample 1, and Alexandra, you can go ahead and do sample 2. So basically just calculate your z-scores for all 10 of those weights that you have in your samples. And then we will go ahead and see what kind of z-scores we're coming up with, and see, are there any balls that are too big or too small? So again, George, you're doing sample 1, and Alexandra, you are doing sample 2. So like I said, you can use the calculator that's in, just what Google Sheets gives you, or you can use a handheld calculator and type your number in. I would say probably just, do the equal to, parentheses, take your sample weight minus the mean, which is 15 pounds, close parentheses, and divide by your standard deviation, which is 0.1. All right, very nice, George. I see that you are done. Yeah, and depending on if your number is smaller than 15 or larger than 15, your z-scores will be positive or negative. So automatically, just looking at your sample weights, you should know which ones should be negative and which one should be positive. And Alexandra, looks like you are done as well. I'm just checking your answers to make sure they're looking good. Okay, and then of course you guys should be able to see the results I have for sample 3 over here. So just looking at your own samples where you calculated the z-score, was there any bowling ball that was a weight that was concerning for it to be too big or too small? And remember, we're basically saying if it's less than 14.9 or more than 15.1, it would be too small or too big, respectively. So any weight that seemed concerning in either of those samples. And I'm looking at sample 3 and nothing really stands out per se. Alexandra, are you seeing anything concerning in your sample 2?
Not really, no.
No. Yeah, and looking at your z-scores, I mean, they're all, within -1 and +1. George, what about you in sample 1?
Yeah, I'm not seeing any issues.
Yeah, the only one that kind of really gets close to that threshold is that last one, right? Where you're right at 15.1. But other than that, I mean, you're well within, like I said, -1 to +1. So they are staying close enough to that requirement of 15 pounds, standard deviation of 0.1. Now, just for comparison's sake, you will see I've also included space here to put our mean and standard deviation for each of the samples. And of course, you will be doing that using just the weights, not the z-score. So go ahead and calculate same sample. So George, you're doing sample 1, Alexandra sample 2, and let's see what our mean weight for each of the samples comes out, just to see again how close each of the samples were to what we were looking for. So remember, just use your built-in functions. For mean, you can use the average function. And for standard deviation, again, the question is, do you use the dot P or the dot S function to calculate your standard deviation?
Dot S.
Yeah, very nice, because you are doing a sample. So you need to use the dot S. Very good. Because, of course, our population would be all 10,000 of these balls, and we don't have the weight for all 10,000 of them. So let's see, that's the dot S. And Alexandra, I'm going to round your answer to 3 decimal places, because of course the raw answer comes out to be pretty large. All right, very good, George. So let's round that down to 3 decimal places as well. So again, you can see for each of the 3 samples, we are just, a hint above 15 pounds, but nowhere close to 15.1 or, larger than 15.1. Again, your standard deviation stays well below 0.1. So that's another way to kind of see, yeah, we're keeping good with our weight requirements, and we're very close to, being where the company needs to be. So at this point, just looking at your z-scores and the mean and standard deviation for each of the samples, what kind of conclusion can you draw in terms of, the 10,000 bowling balls they are manufacturing to be shipped to, whoever the customer might be? Are we well within the requirements, or do we need to go and recalibrate our machines or anything? So what kind of conclusion can you draw based on what you saw for your z-scores and the mean and standard deviation for each sample?
We are in the requirements.
Yeah, because the only ball that even got close to, reaching that threshold was that 10th ball in sample 1, which was right at 15.1, right at a z-score of 1. But again, it didn't go beyond 15.1, so we were safe. Outside of that, everything else is well within range. So yeah, I would say we are good to go. There's no need to make any changes. Now, to try and come up with a graph of this example, what would a normal distribution for this example look like? Now, what kind of shape do we expect, guys, when we are working with a normal distribution or a normal probability graph?
Bell-shaped?
Yeah, remember, it's bell-shaped and it has symmetry. So the idea is when you're working with a normal distribution, your mean falls right in the center. And honestly, the way this works is your mean, median, mode are all going to be at the same location. So the idea is, you have that, as it's called, the bell shaped or the bell curve because of the shape you get. So right in the center is where you should have your mean, and your mode and median are also the same value when you're working with a normal distribution. So in this example, of course, we expect that to be 15 pounds. And then when you talk about 1 standard deviation above and 1 standard deviation below, of course, since our standard deviation is at 0.1, you should be at 14.9, 1 standard deviation below, actually. Hold on. So if this is 1 standard deviation below, that should be 14.9 pounds. Of course, normally we associate mean in a standard normal curve as being at 0. When you are 1 standard deviation above, which is +1, you would, of course, in numbers be at 15.1. And, of course, it keeps then decreasing in that same increment. So if you are 2 standard deviations below or 2 standard deviations above, 3 standard deviations below, that should be a minus. 3 standard deviations below or 3 standard deviations above. So what do you expect these numbers to be once we start going 2 or 3 standard deviations away from the mean? What should we have here for the -2 and -3?
14.8, 14.7.
Yeah, because you keep going down by that same standard deviation value, right? So you go down by another 0.1, which would put you at 14.7. And then on the higher side, George, do you want to try that?
Maybe 15. I mean, would it be 15.2?
Yeah, you keep increasing by 0.1.
Okay.
Very good. Yeah, and the last one?
Yeah, 15.3.
15.3. And then remember, guys, this is where that empirical rule that you looked at in chapter 3 comes into play. So we know within the first standard deviation away from your mean, which would be this area here, we have the 68% of your total data values. If you go out 2 standard deviations, that would be, all of this area then under your curve, which would of course include the center, 1 standard deviation and 2 standard deviations below. Do any of you remember what that second level is in the empirical rule?
Is it 13.5?
No, it's going to be larger than 68, right? Because it's all of this area now.
Mm.
And you guys kind of looked at that, you know, in the empirical rule that you see in chapter 3, but it's okay if you don't remember, because this area going from 2 standard deviations below the mean to 2 standard deviations above the mean is the 95% of your total data values. And then the last one, of course, would be 3 standard deviations. And let's see, for 3 standard deviations, you are going from here and everything in between. So you're taking all of that area in 3 standard deviations. And with your 3 standard deviations, oh Lord, I'm trying to remember this, 68, 95, I think it's 99.5. And that only leaves you, and so you can see we are right at 100%, but not quite, because it does leave a little bit of that area which falls, you know, kind of what we call as the tail area. Hold on a second, I am confusing myself with the percentages. Oh, that's not the one I meant to go to. I want to see your textbook. So under reading, 68.95. Is it 99.5? Oh, it won't let me go through here for now. So let's go back up here. Go under MyLab statistics and then textbook from here. Do you guys remember this from when you guys did the empirical rule? What your percentages are?
Yeah, I think it's 99.7.
Was it 99.7?
Mm-hmm.
Okay. Yeah, and you can kind of see they kind of describe to you know what happens as you keep increasing your sample size. So that's actually a really neat graph over here, because they're just showing you how as you increase your sample size, you get a much better defined you know, bell curve, that shape that comes along. So definitely, if that is something you have not looked at, you should. Additionally, as I'm kind of going over this, you can see how they are talking about, you know, if you have a different mean but the same standard deviation, basically the shape of your graph will stay the same, but you know, it will move depending on where your mean is. It can move to the right or left. So this is where you have a different mean but same standard deviation, the shape of your graph stays the same. On the right hand side, where you can see kind of that taller bell curve over there, that happens when you have different standard deviations but same mean. So they're just talking about, you know, how when you do comparison, you know, some of these things can make a difference in your calculation. And there we go. So yeah, 68%, 95%, and 99.7. Very nice, Alexandra. So yeah, it is 99.7 for the last one. So I was off by 0.2 there. Okay, let's fix that. So that should be 0.7. So that means how much are we left with in this tail area then, at the very extreme edge of our graph? If you have, you know, 99.7 going from -3 to +3 standard deviations from the mean. Because, you know, the entire bell curve has to be 100%, right? So what would we be left with?
0.3, right?
Yeah, 0.3. And the way that works is because, of course, again, there's symmetry. You have tail at each end of your bell curve. Basically, that 0.3 will also get divided into two parts, which will then actually end up, that total is going to be 0.3, but that means each area here is basically going to be 0.15. And again, these are obviously in percent. So as you kind of saw in your textbook, because of that property of symmetry, basically right where your mean is in the center, it ends up breaking your graph into two equal halves. So the idea is from the mean all the way till the end on the left, you will have 50% of your data below the mean, and you will have, of course, 50% of your data above the mean, and then everything else gets broken up into equal halves. So if you have 68 here, then that means each side of the mean, you are going to have 34%. Of course, with the 95 in the middle, what will that come out to be? 47.5. So all of these things are basically going to play into as you start looking at, your bell curves, your normal curve. So what we are going to do is try and come up with a bell curve based on our example over here. So you will see I've kind of given you the formula over here in the yellow at the top where it says normal dot distribution. That is where you put your data value, then what your average and standard deviation is. And for the last parameter, we always say false, so that one will not change. So the first thing we actually have to do is come up with these weights for our normal distribution. We know 15 is going to be the mean, but we also need to be able to go, those 3 standard deviations above and 3 standard deviations below the mean. So as you take your cursor along each of these cells on the weight column, you will see it does pop up with little instructions that I have put in. So the very first one on the top says it should be equal to mean minus 3 times the standard deviation. The one on the bottom will say it's got to equal mean plus 3 times the standard deviation. And then in the middle, it actually has to increment in an evenly manner so that, we can basically go from 3 standard deviations below to 3 standard deviations above. So let's start with that very first one. So this is going to be our mean, which is 15 pounds. And then from that, we subtract 3 times your standard deviation, which your standard deviation, of course, is 0.1. And we already did this calculation, so we know it's got to come out to be 14.7. If I repeat that same thing, but instead of subtracting 3, we are going to be adding it, and I'm just going to move that formula, just do a copy paste and change the -3 to a +3. That will tell us what our 3 standard deviations above the mean should be, and you will see our above the mean should come out to be 15.3. So now we have to find, do we increment this by 0.1? So do we go 14.7, 14.8, 14.9? Is that the increment we need to go with, or what should our even increase should be so that we can get from 14.7 to 15.3? So what do you think will work? So we have a nice flow, going from those numbers. Because let's see what happened if we did 14.8. I'm in the wrong place. Okay, so what if we did 14.8, 14.9? What would that be? 15.0. And so you will see we're going to reach 15.30 much sooner before we get to the bottom of the table. So 0.1 is not going to work. So what else should our increment be? So take a minute, think about it, do some calculations if you want to try writing it out and see how you can move through. Let me see what you suggest as our increments should be.
We could try 0.05.
Okay. So basically that means your next one would be what?
14.75.
Okay, so incrementing by, so that would make it 80. Okay. What would that be? 85, 90. So far we are looking, no, I'm still in 14, 9095. So this will be right at our mean of 15. Okay. What would this guy be? 05, 15.10, 15.15. Okay, this is looking really good so far, which would put this guy at 15.25, which would then take us to 1530. All right, beautiful. Okay, so now when you are doing your normal dot distribution, this is where you are going to be using this norm dot distribution function. Now, this is where you put your data value. So our data value, of course, is the weights that we just came up with. Comma, you need to put your average. Now, you can do a cell reference where you click on the cell, which is kind of what I was doing before. However, one thing, again, you guys have to keep in mind that weight is going to keep changing, right, for each of the cells as we go down the list. But our mean and standard deviation is not going to change. Now, you can definitely type in 15 and 0.1, but it's kind of one of those things. If you use cell reference, then you don't have to go back and make those changes if you change your mean or standard deviation. So since the mean will stay the same for all of these calculations, remember you put those dollar symbols around the cell value. For standard deviation, we're using 0.1. So I click on the cell again and put dollar symbols around my cell number. And then the last one, this is the parameter, because it's talking about cumulative, this is where you're going to say, well, that's going to be false. And what this does is it actually calculates, what that quantity, what that value for normal distribution is going to be. And we need that to be able to come up with our curve. And this will autofill because this will stay the same. And you can go back and verify that, it's using the next weight for the corresponding cell, but then you will see my standard deviation and mean will stay the same because we put those dollar symbols around. So you can verify that for each of these cells and you will see it comes out to be fine. Now, the last one was actually not a value, so that's why it's giving you an error there. So I'm just going to delete that because we didn't really need that cell. But now you've got your standard deviation, normal distribution values, and you guys should notice that pattern of symmetry over here, because again, this is coming from that idea of this is a bell curve, a normal distribution curve, and it's going to be, obviously symmetrical. Now you can see I've put the instructions over here for graphing. So you select the weight and your normal distribution columns, and then you just do a smooth line chart when you are graphing this. So we'll go ahead and select both of our columns from 14.7 down to 15.3. Go under insert and then chart. So you will see it automatically picks a line chart, but it's kind of doing like connecting the dot kind of thing. So it's not a very smooth curve. And this is kind of where we need to change that. So when you come under the setup option, go under the chart type, you will see under the line graph, you have that smooth line chart. And as soon as you click on it, it, gives it a nice continuous look instead of, connecting the dot kind of look to it. But you can see this looks very, very similar to what we had done. Unfortunately, since we only did our table going from 14.7 to 15.3, this is showing you exactly 3 standard deviations above and below the mean. So we don't have, that tail area. And this is basically where I would probably suggest, coming in and doing some editing so that we can decrease, some of those values. So we could do, I don't know, 14 point, maybe 6.5 to, 15 point, what was it, 3.5? To just get a little bit of that extra space around. And, again, technology can only take you so far. So we just have to remember that there is going to be a little bit of that tail area because, of course, you have that 0.15% of your data value on each side of your graph. But, you can see it's still pretty decent, right? I mean, it's got the normal curve. We can see where our mean is, which is right there at the center. So that's your 0. This is your +1, +2, +3. So it's 3 standard deviations above. And then here you can see -1, -2, -3, which would be 3 standard deviations below. And then basically we were trying to do for our example is we wanted to make sure our weight of the bowling ball stayed within this region. So it had to be right part of that very center where all of our bowling ball weights had to be. And we already made that conclusion looking at what our z-scores looked like, looking at what our mean and standard deviation for each of the samples look like. And we definitely could make a good conclusion based on that. The normal chart just kind of helps you verify that, yeah, we did stay within that area of the 68% where we needed our weight for this production of bowling balls to stay. So any questions on this, guys? And, of course, you can use a lot of these built-in calculations, and there's more that you can kind of play around with. Let me just very quickly show you. And I've shared this with you guys. You know what? Let's just go here. So I've shared this with you guys, maybe right here under MyLab statistics. So you will see there is a PDF document. So this one has all the formulas and tables that your textbook has. But then Professor Ray Brown has created this formula sheet, and it's on his personal webpage that he keeps. So if you go there, you will see he's broken this down by what the formulas in the book look like and what your spreadsheet, built-in functions would be. So this can be for Google Sheets or Excel, they're kind of parallel in that sense. So you can see he's done that for different chapters. It kind of starts at officially at chapter 3, but he's given you something from the previous chapters there. But chapter 3, you can see chapter 5 is in here. Chapter 6, he kind of shows you how to break that down. And right now you're working on chapter 7. So we just use the normal dot distribution formula, but you can see there's the normal dot s dot distribution, normal dot s dot inverse, normal dot inverse, and then of course the standardized function. So there's all kinds of built-in functions that Google Sheets and Excel have. There's some here for chapter 8, and it keeps going for the next chapters that come up. And then, we'll start using StatCrunch in some of those later chapters. So instead of working with Excel, we'll actually move on to StatCrunch because they have built-in calculators, which will really make our life a lot easier. So we'll talk about that when we get to those chapters. But this is a great resource to have, guys. So I will definitely recommend you to kind of look through this, play around with it. But basically, are you guys feeling comfortable at least with what we did here with the normal distribution? Any questions that kind of pop up in your mind right now? No? Okay, so again, if you have not had a chance to send a request for your password for this week, go ahead and do that. Send your email, and I'll start sending those out later today or maybe tomorrow. So we're kind of getting into the second half of our session over here, guys. We're in week 5. This is an 8-week course. So week 6 and week 7 is where, we'll be working on finishing up the last remaining part of our coursework. Now, I also wanted to remind you during week 7, which is where you guys work on chapters 11 and 4. So those are the smaller chapters with only 3 sections total. So I will actually give you a chance during week 7 to go back and work on any older homework or quizzes if you wanted to. So, anything you want to bring your grade up to, if you're at 90%, but you want to do 100%, so your overall grade can go up, you can do that. If out of your quizzes you have any tries left, so you get 3 tries on your quizzes, right? If you haven't used all 3 of them, you will be able to go back and work on the quiz as long as you have, one of the attempts left. Also, I will give you a chance to work on one older chapter exam. So you can retake one if you missed it, or you can retake one if you got a low grade and you want to try and see if you get a higher grade. But all of this will happen in week 7. You will still need to have 90% grade on all homework sections, even if you want to retake an exam. If you don't have 90% on homework sections, obviously that exam will not open for you. So that requirement will still be there. And the reason I'm telling you that is, I don't want you to get too overwhelmed. But now that you don't have any D2L assignments and discussion posts, I'm kind of hoping that's taking a little bit of the stress away. Because, we are getting into some deeper context of statistics. So some of this can take, more work from you to break those problems down. Some of these are multiple step problems, so they can take, 4 or 5 steps before you finish the examples and stuff like that. So take it easy if you have to. You will get a chance to go back and try for a higher grade, but obviously you can only retake one chapter exam. So I would say, probably go for the one that you scored poorly on and you want to try and get a higher grade. Having said that, if you retake it and let's say you didn't do as well as the first time you took it, you get to keep the higher grade. So we'll always go for the higher grade. So that will be happening in week 7. Now our week 8 is actually kind of a shorter week because week 8 will begin on Monday and it ends on Friday because that's when our class ends. On week 8, which actually goes from October 10th through the 14th. So on October 12th, when we meet for our Zoom session, you guys will actually be taking the in-class version of your final exam. It's going to be an hour long. It's not going to be very long, but you will be taking your in-class version of the final exam during class. So, it's going to be a little bit more of the simpler questions. So it will be some terminology, some concept questions, some of the basic, not, big 5-6 step involved kind of problem. Then you also have a take-home version of the final exam, which is going to be longer. And that is where you will have more of the complex problems in there. So just keep in mind that will be happening in week 8 of our classes. So you do have the in-class and the take-home version of your final exam. You'll kind of start seeing more of this information start showing up in your announcement and stuff as we get closer to it. But since we had a little bit of time, I figured I'll talk to you about that. So anything just in terms of queries or concerns as we're kind of heading towards those last couple weeks of this class? Okay, if you guys don't have any questions, then that was our activity for today. Next week, we will be working on chapters 9 and 10, which is where we start getting into hypotheses testing and confidence intervals. So we'll talk about that next week. So again, guys, please don't forget to send me your email request for the password, and I'll see you next Wednesday. So have a wonderful morning, everyone. Be careful. Take care. Bye-bye.